Hey guys, shall we start? So, the industry left discussed now is HCl production. It's a small part, but questions can be there. So, better to discuss. Now, come to the production of HCl acid. Take out the tubes. Now, whose tube is this? Yours. Right? So, the production of HCl acid. Right, various reactions can be used to produce hydrochloric acid. So, there are like main three ways of producing the hydrochloric acid. First one is chlorination reaction of organic compounds. Now, this is the mostly used method to produce the HCl, like the chlorination of organic compounds. Now, this comes under the PVC production as well. In the PVC production, as a byproduct, HCl is also produced. We will discuss that, right? So, the next one is reaction between the H2 and Cl2. So, hydrogen gas and the chlorine gas are reacted together to produce what? HCl. That is the second method of it. And the reaction between NaCl and concentrated SO4. This should be SO4, sulfuric. Sodium chloride and sulfuric reaction. Sodium chloride reacting with the sulfuric produces the HCl. Right. HCl is a byproduct of the chlorination of organic compounds. HCl is produced in the production of vinyl chloride from ethene, right? Now, this is what happens, right? So, vinyl chloride is produced using the ethene, right? So, vinyl chloride is produced using the ethene. How the ethene is reacted with chlorine gas. So, this is vinyl chloride. Now, vinyl chloride is what? Monomer of PVC, right? Monomer of PVC. Polyvinyl chloride is there. So, now using the vinyl chloride, we can produce the HCl. Now, write this down as this is ethene, chlorine gas, this is vinyl chloride. Ethene, chlorine, vinyl chloride. Right. Now, this is not ethene. This is ethene, this is chlorine, this is vinyl chloride. Right, vinyl chloride. Right. So, vinyl chloride is reconstructed or like with the one hydrogen atom in here, HCl, like one of the chlorine is reacted, right. So, this is actually what happens here. So, now here there is a hydrogen atom, two atoms are there, right. So, there is the two of the hydrogen atoms are like this, one hydrogen and the next hydrogen, right. So, the two of the hydrogens are like this. So, this one of these hydrogen atoms and chlorines are getting together and forms HCl, right, and this is formed, right, this one is formed. So, that is what happens, right. The vinyl chloride obtained from this is used as a monomer for the production of PVC. Now, this is not the vinyl chloride, this one is the vinyl chloride, right. This is the vinyl chloride, this one is the vinyl chloride. This is dichloroethene. This is dichloroethene. Dichloroethene. Right. This is vinyl chloride. Dichloroethene and vinyl chloride. Right. So the vinyl chloride obtained from this is used as a monomer for the production of PVC, right? මෙන්න මේ complete compound එක තමයි vinyl chloride එක. මෙයා vinyl chloride. Right? So මෙන්න මේක වැදගත්. මොකද්ද? Vinyl chloride obtained from this is monomer for the PVC නේ. So මෙයා by product එකක් HCl වල එයාව අපි PVC වල monomer එකක් විදිහට use කරනවා. And this one as well. The main method of producing hydrochloric acid is chlorination of organic compounds. Chlorination of organic compounds කියන එක තමයි main method එක. මේ methods තුනත් වැදගත් හොඳ. මේ තුන මතක තියාගන්න ඕන. ඔක අහනවා. Chlorination of organic compounds, reaction between hydrogen and chlorine, reaction between sodium chloride and concentrated sulfuric. They all important. Right? Right. So that's it. That's HCl production. Right. මෙන්න මේ තුන මතක තියාගන්න. ඊට පස්සේ by product එකක් විදිහට vinyl chloride හැදෙනවා. එයා PVC production එකට ඕන වෙනවා. ඊට පස්සේ main method එක තමයි අර තුනේ organic compounds chlorination වලින් HCl හදන එක. හරි. ඔය points මතක තියාගන්න. MCQs වලට එහෙම අනිවාර්යෙන් ලොයිත් අහන්න. Right. Come to the soap and detergent production. So the soap can be produced at home, right? Homemade soaps can be produced, and some are doing it as a business as well. But the trouble is, like majority of the soaps that are producing have excess caustic soda or the sodium hydroxide. Then, if you applied it in your body, that's the end of your body. So, like if you know the process, you can still manage to have the side effects, right? To reduce the side effects, you can manage it. Right, come to the soap and detergent production. Soap is made of vegetable or animal oils, right? So mainly the vegetable oils. Sometimes a mixture of vegetable and animal oil is used. Now the chemically soap production involves the hydrolysis of triglycerides. That's important. So what happens is the hydrolysis of triglyceride occurs. We call this a separate name, right? When in the soap production, the hydrolysis of the triglyceride occurs, right? That means the triglycerides are divided into two parts using the water molecules, right? But in this case, like the sodium hydroxide is actually used. Sodium hydroxide is actually used, right? So this process is called a different or separate name. What do you call this? Saponification, right? So hydrolysis of triglycerides is a saponification action, right? Huh? Saponi. Yeah. Saponi here. Saponification. Saponification, yes. No, the girls like the soft words more than the You know the hard words. The P is hard, the F is soft, I guess. Hopefully, yes. With the caustic soda, right? This is called saponification. Yeah, I can sound it sapo, but it's actually sapo. Yeah, yeah. Right? To form sodium salts of glycerol and carboxylic acids, right? So the end products will be to form the sodium salts of glycerol, right? And carboxylic acids are produced at the end. We'll discuss it, right? The salts are called soap. Now this is what happens is, right? So this is what triglyceride. So these triglycerides are divided into glycerol and these are the salts of carboxylic acids, right? Now this is divided into two. One is the glycerol. I'll show it to you. So this is what happens. Now the NaOH is dividing this into two parts, right? So the NaOH is there. So it's dividing this into two parts like this. So Na is attached, it's actually the other way around. Oh, anipatharin. It should come at this point. Yes. Sometimes they may ask it. කොහෙන්ද කැඩෙන්නේ කියන එක. මෙතනින් මේ පැත්තෙන් කැඩෙන්නේ. So they gets the OH. These people get the OH. And these people get the sodium. Right. එතකොට හරියටම කැඩෙන්නේ කොහෙන්ද? CH2 මේ කාබන් හරියෙන් කැඩෙන ඔක්සිජන් එකට මෙහෙන් තමයි කැඩෙන්නේ. So what happens? The OHs are taken by the glycerol molecule and the sodiums are taken by the carboxylic acids or the fatty acid molecules, right? So the glycerol is produced, which is the byproduct, and the main product is the sodium salts of fatty acids or the carboxylic acid. So the sodium salts of these fatty acids or the carboxylic acids are called soap, right? So this part is the soap. What are the soaps? The sodium salts of the long chain fatty acids, right? The sodium salts of the long chain fatty acids are the soaps. Shall we write it? Sodium salts of, make it clear, sodium salts of long chain fatty acids. Right. මේ බ්‍රේක් වෙන පොයින්ට් එකක් තියාගන්න. ඒක ඕන ඉම්පෝටන්ට්. ඒක මතක තියාගන්න සමහරක් කාට අහනවා. කොතනින්ද බ්‍රේක් වෙන්නේ? මේ පැත්තෙන්ද මේ පැත්තෙන්ද? So simply what happens is sodium එක මෙයාට යනවා, OH එක මෙයාට යනවා. That's all. ඒකෙන් decide කරන්න කොහෙන්ද කැඩෙන්නේ කියලා. And or else මතක තියාගන්න මෙන්න මේ ඔක්සිජන් එකට මේ පැත්තෙන් කැඩෙන්නේ කියලා. අහන්න පුළුවන්. නැත්නම් ලේබල් කරන්න එන්න පුළුවන්. කොහෙන්ද කැඩෙන්නේ කියලා. නේ? Right? Right. Right. So three of the NaOHs react with the triglyceride molecule and forms a glycerol molecule and three sodium salts of long chain fatty acids, which are soap, right? Right. So there are four main steps involved in the soap production. First one is saponification, which is this reaction that we discussed, right? The second part is removing the byproduct glycerin. You have to remove the glycerin, right? It's an additional part and it's more expensive than the soap, glycerin. And the third one is soap refining. You have to refine the soap. For that we are using a salt mixture or a brine water, we call it. We are using the brine water or a salt mixture. Why do we use like a salt water to like separate the soaps? He uses, huh? No. we are using a salt solution to separate the soap. There's a good reason for that. And there's an equilibrium of it, right? So now this is the soap molecule, right? Come to this one. So this is what actually happens is, right? So R, now I'll take it as R, the carbon chain as R, R C double O minus sodium plus. This is soap, right? The long chain fatty acids of like the salts of long chain carboxylic fatty acids, right? So these soaps are breaking into, like it's reacting with water, no? So when it's reacting with water, this soap molecule breaks into two parts, which is a ionization process, right? Like this dissolved in the water means ionization, right? So R C double O minus plus sodium plus, they are breaking down into two. So this is simply dissolving. This is what means dissolving, right? So this is simply dissolving. Now this is undissolved soap, and there is an equilibrium here. We discussed this earlier. When there is an equilibrium, if a disturbance occurs to the equilibrium, what does the equilibrium do? It changes the equilibrium to remove the disturbance, right? So let's say I am increasing the amount of sodium ions in the solution. What happens to the equilibrium? The equilibrium rebuilds itself to remove the excess sodium ions. So to remove the excess sodium ions, to where should it go? The forward reaction or the reverse reaction? The reaction of the reverse reaction occurs more. So what happens then? The reverse reaction occurs more means the soap becomes dissolved or undissolved. Soap becomes undissolved. So if you want to separate it from the water, would you have to make it dissolved or undissolved? Undissolved. So that's why you put salt water, and that's why you don't apply soap when you are bathing in the sea, do you? You don't apply any. No, you don't. You can't. If you apply any soap in the sea bath, what happens? It will make like the clumps, you know. The clumps will be forming, like the foam, like the clumps that don't dissolve will be forming. You can't apply any soaps in the sea water. Oh, nobody applies soap in the sea water. Right? Oh, it doesn't dissolve because the number of sodium ions in the sea water is high. Right? Oh, හැම මේක තමයි වෙන්නේ reaction එක. Right? So it's about the equilibrium. Right. So come to this one. When considering a soap molecule, it is possible to name regions with hydrophobic tail. Highlight it. So it has two the regions. One is hydrophobic tail, which is this one. Right? This is the hydrophobic tail. Containing carbon and hydrogen atoms and a hydrophilic head. The other one is hydrophilic head. So two parts are there. One is hydrophobic tail, the other one is hydrophilic head, right? Hydrophobic tail and the hydrophilic head. Why is it important to have like two of the regions, hydrophobic tail and hydrophilic head? Yeah, like the two of the things are happening. One is this, when you are applying soap in the bathroom, what happens? Like if you have a, let's say a oil spot somewhere in your t-shirt or in the body, let's say, in your shirt, there's an oil spot. What happens now? Now this is the oil spot, right? This is the oil spot. and we can like draw the soap molecule as this. Now this is the hydrophilic head and this is the hydrophobic tail. Now what attracts the oil spillage? The tail, right? So tail comes and attach around the oil spillage, and what happens now? Now the oil doesn't usually dissolve in the water. Now what happens now? All the tails are catching up with the oil spillage and removing it and also dissolving in the water because all the hydrophilic heads are around. Get it? So that is what it does. So let's say now this is a oil spillage, right? And let's say a blood stain is there, kind of a blood stain, something like this is there. A blood stain is there. Now what happens? Yes, the heads are coming and bonding with the the blood stain, and now if it is in the water, what does it make? It makes a bit of a foam there. It makes a bit of a foam there. Get it? It doesn't completely dissolve. Yeah. Now this is a blood stain. So now the blood is hydrophilic. Blood is usually hydrophilic. Yeah, it dissolves in water. The blood itself dissolves in water, so it's hydrophilic. So if there's a blood stain in your shirt, what the soap does it? The soap heads are attracting the blood smear, and it removes it from the cloth because the bondage here is greater than the bondage with the cloth. So it removes the stain, and rather than saying dissolving it, it makes a little bit of a foam there because the tails are now outwards, right? Because the tails are outward, doesn't dissolve completely in the water, so makes a bit of a foam. Have you seen it like when you like apply the soap? Sometimes when there's more of the dirt, it makes a bit of a foam. Now this is why, right? So there's much of more hydrophilic compounds there, right? So this is the hydrophobic action. This is the hydrophilic action. Now the hydrophobic action to remove all the hydrophobic compounds or the organic compounds, because the organic compounds are mostly the hydrophobic parts like the oils, and the hydrophilic parts are to remove most of the hydrophilic stains like the blood stains, sort of like, right? So both of the head and tail can remove the dirts. Get it? That is what it does, right? That is how the soap works, right? So now the hydrophobic tail is there and the hydrophilic head is there, and the two of the head and tail are working to remove the stains or the dirts, right? So the number of carbon atoms in this soap molecule varies 12, 14, 16 and 18, because now if these are the vegetable oils, now the number of carbons in the vegetable oils are usually, or the number of carbons in the fatty acids of the vegetable oils are usually in the even numbers, like 12, 14, 16, 18, they are mostly the even numbers, right? So it can be 12, 14, 16 and 18. About 52 to 44% of coconut oil is lauric acid. We discuss a bit of this under the biomolecules, right? So nothing much to worry about. It has 12 carbon atoms. This is about the lauric acid. Of these, 11 atoms are associated with the hydrophobic tail, right? Now the 11 carbons of it are associated with the hydrophobic tail, and now the myristic acid, which contains 14 carbon atoms, is 14%. The amount of palmitic acid in coconut oil is, the amount of palmitic acid in coconut oil is 8%. Now මේ විදිහට myristic එකේ තියෙන්නේ 14%. ඊට පස්සේ the amount of palmitic acid in coconut oil is 8%. Palmitic acid has 16 carbon atoms, the amount of stearic acid, which has 18 carbon atoms, is 3%. Oleic acid has a double bond with carbon atom 18. It is present in coconut oil in an amount of 5 to 8%. Therefore, soap is a mixture of sodium salt formed due to a mixture of such acids. Do you get it? Like the soap is not just a one compound. It's a mixture of like the salts of fatty acids, right? Because the number of fatty acids are different in a oil. So they are all making the salts, and the soap is a mixture of all that fatty acid salts, right? So to remove pigments and impurities from the oil, it is passed through a special clay liquid called activated Fuller earth. Now highlight that one. Now sometimes, right, the oil might contain pigments. Color pigments are there, right? If the oil contains any color pigments, what they do is they are putting the oil through this activated Fuller earth. What does it do? It removes the color pigments, right? That is something to remember. Now to remove color pigments, activated Fuller earth is used, right? Its temperature is maintained at 90 degrees of Celsius when putting through it. After removing any clay particles that may be present in this oil, it is used to produce soap. Clay particles මොන හරි තියෙනවා නම් ඒක අයින් කරන්න ෆිල්ටර් කරනවා. ඊට පස්සේ තමයි soap හදන්න ගන්න. Soap production can be done in a continuous process or a batch process. Batch wise හදන්නත් පුළුවන්, continuously හදාගෙන යන්නත් පුළුවන්. So usually what they do is they make it batch process, because if any of the trouble came, they can find it out from which batch the problem occurred and the reason, right? Maybe the people who did the batch that day, maybe the visitors who came that day, they can find it out, right, using the batch process. Right. The batch process is the traditional method. In the batch process, all the ingredients are added to the reaction chamber at once, and the reaction is allowed to process. The oil is added to the reaction chamber, and NaOH or KOH is gradually added to initiate the reaction or the incubation. This reaction is exothermic because it is neutralization reaction, right? So because it's an acid base reaction, so the fatty acids are acids and NaOH are the base, so it's a acid base reaction, so it's exothermic. So highlight those things. The chamber and NaOH, KOH is gradually added to the initiate the reaction. This reaction is exothermic, right? So the saponification reaction is exothermic. Even mixing the water with sodium hydroxide is also exothermic. As the exothermic reaction proceeds rapidly, the remaining NaOH or KOH is added all at once. It's important to control the temperature as required, right? In a continuous process, the reactant is pumped into the reaction chamber. The reactant is pumped into the reaction chamber at a certain rate. එතකොට අරගෙදි කරන්නේ certain rate එකකින් එක දිගට pump කරගෙනම යනවා. හරි continuous එකකදී යන්නේ. The products are removed from the reaction chamber at a certain constant rate. ඒතර හැදෙන ඒවා ටික පල්ලෙහෙන් remove කරනවා. reaction chamber එක මතකනේ. උඩින් add කරනවා පල්ලෙහෙන් remove කරනවා. ඒතර අරගොල්ලෝ certain rate එකකින් add කරගෙන යනවා. පල්ලෙහෙන් certain rate එකකින් remove කරගෙන යනවා. For example, the oil is pumped at a rate of 657.4 kilograms per hour and 50% weight by weight NaOH solution is pumped into the reaction chamber at a rate of 101 kilogram per hour. Therefore, if the material is not removed from the reaction chamber at a rate of 758.4 kilogram per hour, the reaction chamber will be completely filled. නේ අරගොල්ලෝ ඇඩ් කරන රේට් එකත් එක්ක මෙයාව මෙන්න මේ රේට් එකෙන් අයින් කරන්න ඕන. Otherwise it will completely fill the chamber, right? මෙයා ඒ කියන්නේ value wise මතක තියාගන්න ඕනේ නැහැ හොනේ. This is just the detail. The reaction chamber will be completely filled. The volume of the reaction chamber must be such that reactant entering at this rate has enough time to become the products. A soap manufacturing process can be illustrated by the following. Now this is what happens in the soap production, right? Right. So come to this part. So what happens here? Caustic soda and the oil mixture are mixed together. I can't speak while eating. Right. So the oil mixture and the caustic soda solution are mixed together in the reaction chamber. What happens? The saponification reaction occurs. That means the soap is produced. Right. Soap is produced here. This is in the chamber. And when the soap are produced, what do? We add a, no, listen, right? So the oil mixture and the caustic soda is added to the reaction chamber. So the saponification reaction occurs. That means the soap is produced here, right? And while the soap is producing, we are adding a salt solution. What for? To make the soap more solidified or hardened, because it will be dissolved in the water after the reaction, right? The reaction occurs and the soap will be dissolved, right? So to separate the soap from the water, we have to add the salt solution, right? So now the solidification or the clumping of the soap happens more, right? So once the salt solution is added, we can get separately the unrefined wet soap, and the solution or the water solution goes here. The water solution contains what? Glycerine. So you have to separate glycerine from the water solution, right? And unrefined soap is again acted with a new salt solution, right? The water separated the glycerine, again comes down and added with a new salt solution and comes to the unrefined wet soap, right? Still the water is there, so bit of a, like much of a amount is still dissolving. So because of this new salt solution, what happens? The excess, right? The excess glycerol will be dissolved in that water, and more of the soap will be separated from the water solution. Get it? Because the glycerol is dissolving in water, though it is salted or the ionized. But when more the sodium ions, more the ionized, the soap becomes less dissolved, right? So more undissolved salt is undissolved soap is separated, and the dissolved glycerine is taken with the water, right? So the more of the glycerine is removed here, and more of the undissolved soaps are produced here because of the salt water. Now the glycerine removed, washed wet soap is produced here, right? So the next step, what happens? The centrifugation occurs. What is centrifugation? We are rotating it in a, yes, like we are rotating it in a basin, that all the components there in the basin will separate depending on their mass, right? So the water layer, like the things that contains here is mostly the water and soap, right? So the water and soap will be separated into two layers in the basin, right? So the one layer is water, the other layer is soap. So the centrifugation, we can separate the water and soap, and the wet soap is removed, right? Now the wet soap is removed. Now centrifugation, the water is removed as aquatic salt, right? And the wet soap is taken separated, right? Now the wet soap still has sometimes the excess sodium hydroxide, right? The wet soap sometimes have the excess sodium hydroxide, which is, yeah, not good for your skin, and yeah, it's mostly the how can I say, can't say corrosive, it's sort of a corrosive, like it burns your skin, sort of a corrosive, right? So wet soap with bit of a extra sodium hydroxide is neutralized by adding what? Citric acid. So the citric acid is added to neutralize the excess sodium hydroxide, right? Then afterwards, the neutralized weak acid soap is produced. because the excess sodium hydroxide is now removed. Now what happens? Drying under low pressure conditions. Now what they do is, now this is, let's say, a bit of a solidified but still looks like a wet soap, right? Not completely solidified. So what you do is, you pass it through a fan with a low pressure, right? And the temperature is also reducing, right? The temperature is reduced and the pressure is also reduced. You are moving it through a fan. So what happens when it goes to the fan is, when it goes to the fan, because of the low pressure, the water and the soap particles are separating. The water mostly evaporating and the soap is condensed and drops as a dry particles, right? So drying under low pressure conditions, the dry soap occurs, right? So what do you do to the dry soap? Yeah, you shape it. කැටයන් කපලා ලක්ස් වල තියෙන ඒවා තියෙනනේ. කැටයන් ටික කපලා afterwards fillers වලින් යවලා, ඒ කියන්නේ fillers add කරනවා. ඒ කියන්නේ දැන් මේ soap නේ තියෙන්නේ. ඒවාට සුවඳ ඕන නම් ඒවා. ඊට පස්සේ තව මොනවා හරි ඔයාට quality එක වැඩි කරගන්න මොනවා හරි දාන්න ඕන නම් ඒව දාලා fillers දාලා soap එක හදන ඊට additives, colorants, fragrances ඔය ටික add කරනවා. Right? Chlorix? What is Chlorix? Detergents. Detergents are a different case. Now these are ඒකට පාවිච්චි කරන chemicals වෙනස්. මේ තියෙන්නේ soap. සබන් කැටි. මේක තමයි අර ඇඟේ ගාලා රෙදි හොදන්න ගන්නත් පුළුවන්. හරි. Like in most of the cases ඇඟේ ගාන සබන් they use KOH. රෙදි හොදන සබන් they use NaOH. Most of the time. For even the children's soaps, they use KOH. Now different cases are there. Now do you understand the process, flow chart? Now this flow chart will be there, and there will sometimes be questions from this one. Okay, දාන්න පුළුවන්. ඒකින්ද flow chart එකේ අර මේ මොකද්ද කරන්න කියන එක තමයි වැදගත් වෙන්නේ. Right, now the saponification occurs. Why do you add a salt solution? To separate the soap from the glycerin and the soap from the water, right? So in the aquatic solution, the glycerin is dissolved, so you separate it at here, right? And then the unfined wet soap then again dissolves with a new salt solution to remove the excess or the left glycerol amounts and to make it more solidified. And then the glycerol removed, wash wet soap is produced. Then the centrifugation separates depending on the mass. The aquatic salt solution is separated and the wet soap mass is separated. Then the citric acid is added to neutralize the excess sodium hydroxide. The neutralized weak acid soap then again dried under the low pressure. Then it was a cation kapala make the soap. That's it, right? So that's the flow chart. Remember that. Now come to the theory. What? Essential oils like the coconut oil. Okay. Dry කරාම පස්සේ තමයි ඇඩ් කරන්නේ. කියන්නේ ඔක පවුඩර් නේ තියෙන්නේ. නෑ පවුඩර් එකනේ තියෙන්නේ. ඔව්. පවුඩර් එකනේ තියෙන්නේ. පවුඩර් එක තියෙනකොට තමයි ඇඩ් කරන්නේ. ඊට පස්සේ තමයි බ්ලොක් එක හදන්නේ. අර ක්ලේ වගේ තමයි. එකතු කරාම හදන්න පුළුවන්. හයියට. තබා. හරි. Now come to the theory. A mixture of refined oil, coconut oil likewise, or vegetable oil. Is that a phone? One kidney left. Right, come to the theory now. A mixture of refined oil or vegetable oil and animal oil and caustic soda solution or KH solution are pumped into the reaction chamber Then the dissolution of caustic soda in water is exothermic. Highlight it. Now dissolution of caustic soda in the water is also exothermic, right? Therefore, the dissolution of caustic soda NaOH in water is carried out as a separate process. That is also important. Dissolution of caustic soda is taken separately because it's exothermic and the heat is increasing, so you have to control it, right? So first dissolving the caustic soda with water is taken separately, right? Then the oil and aqueous NaOH are immiscible phases, isn't it? Like the oil is a hydrophobic compound and the NaOH is a hydrophilic compound, so they don't dissolve each other, so they are in two like immiscible two phases, right? So however, the saponification reaction that occurs at the interface between these two of the layers, right? So it happens something like this. Let's say this is the chamber. So now let's say the oil is up here and the water and NaOH are here. So what happens? In the interface here, the saponification reaction occurs. Would you keep it like that? No. What do you do now? You have to mix it with a propeller so that the complete reaction occurs, right? So in the interface between these two layers produce water soluble glycerin and soap. The temperature of the reaction mixture is maintained at 70 degrees. Highlight it. Temperature 70 degrees वला reaction chamber के maintain करना होना, right? The oil becomes smaller and the surface area increases. The increase the surface area, the reaction occurs uniformly throughout the entire mixture, right? तर මේකේ mix කරනකොට ඔය තියෙන droplets වල size එක පොඩි වෙනවා. ඒතර surface area වැඩි වෙනවා. Reaction occurs smoothly. So after saponification, the alkalinity or the basicity, alkalinity is the basicity basically, alkalinity of the water phase obtained has decreased. The alkalinity has decreased or the basicity has decreased because NaOH reacted with the fatty acids, right? Glycerin has dissolved in it, some amount of soap has dissolved, right? Now the some amount of soap has dissolved. To remove the soap dissolved in the water phase, a salt solution made by dissolving sodium chloride is added. Now highlight this one. To remove the soap dissolved in the water phase, a salt solution made by dissolving NaCl is added, right? Which point is this? This part, right? Oh, even this can be taken. මේක තමයි. හරි. Salt solution එක add කරනවා. අර dissolve වෙච්ච soap ටික undissolve කරගන්න. Right? Since the concentration of the sodium ion in it is high, the soap molecules formed by combining with the negative ions obtained from soap molecules dissolved in water and ionized are separated from the water phase. Right? So this happens. Now the reverse reaction happens when more of the sodium ions are there, as we discussed. When increasing the sodium concentration, reaction occurs backwards more, right? Which means undissolved soaps are produced, right? Because the brine solution is recycled, there may be some glycerol associated with this NaCl solution. Therefore, this solution is called half spent lye, right? So it's a half spent lye and it's valuable because the undissolved dissolved glycerol are also associated with it, right? Glycerol තියෙන ඉඳ අපි ඒකට කියනවා half spent lye එකක් කියලා. Right? Now the brine solution is simply the salt solution, right? We call the salt solution the brine solution. Brine water කියලානේ කියන්නේ අපි. Right. After the soap and water zone separates, the water zone with glycerin is pumped out and removed, right? The presence of significant amount of water in the foam soap and the temperature at 70 degrees make it easy to pump and remove. This can be called wet foam soap. If there is unreacted oil, a suitable caustic soda solution is added to the reaction chamber and the reaction is allowed to take place. Now, if there is, like, after the saponification reaction, if there is any of the oils remaining, what do? You add a bit of sodium hydroxide to react with those excess oil, right? Now, if there is unreacted oil, a suitable caustic soda solution is added to the reaction chamber and the reaction is allowed to take place. Highlight it. If there is unreacted oil, suitable caustic soda solution is added to the reaction chamber and the reaction is allowed to take place. Right? Excess තිබ්බොතින් ආපහු caustic soda චුට්ටක් දානවා. Glycerin is present in the water zone removed from the reaction chamber. Glycerin එක අපි අයින් කරලා දානවා water වල dissolve වෙලා තියෙන chamber එකෙන් අයින් කරලා දානවා. Therefore the brine is a good source for separating the glycerin as a byproduct. හරිද? ඒතර brine එකෙන් තමයි අපි වැඩිපුරම glycerin එක අයින් කරන්නේ. When a glycerol is removed from the solution, the resulting solution is prepared as needed by adding NaCl solution again. This brine is used to remove glycerin from the rosing soap. Right? Now this rosing soap means is more the wet soap. Wet soap එකේ තව additional තියෙනවා නම් අයින් කරනවා කියන එක තමයි මේ කියන්නේ. Soap does not dissolve in the brine solution. Glycerin dissolves. Here it is very important to mix the soap well with the brine solution. Therefore, glycerin can be removed from the soap scum and refined to some extent. Right? Glycerin is separated from the soap into the saline water zone. This glycerin containing saline solution and the washed soap are separated. The saline solution is used to separate the soap dissolved in the aqueous zone of the reaction chamber. When the glycerin composition in the aqueous zone exceeds 35% weight by weight, the efficiency of the glycerin dissolution decreases. It is important when the glycerin composition in the aqueous zone exceeded 35%. Highlight karaganna. When the glycerin composition in the aqueous zone exceeds 35% weight by weight, the efficiency of glycerin dissolution decreases. මීට වඩා වැඩි වුණාන් පස්සේ glycerol dissolve වෙන amount එක මොකද වෙන්නේ? අඩු වෙනවා. Therefore the glycerin composition in the aqueous zone is maintained between 25 to 35. හරි. මෙන්න මේ ගානේ තමයි හැමතිස්සෙම තියාගන්නේ. මීට වඩා වැඩි වෙන්න දෙන්නේ නැහැ. Soap contains water and NaCl salts. When NaCl presents in the soap, soap does not dissolve in the water and foam well. Therefore, NaCl must be removed. For this, the wet soap containing salt is centrifuged. Then NaCl එක තියෙනකොට soap එක dissolve වෙන්නේ නැහැ නේ. ඒකින්ද salt solution එක අයින් කරන්න ඕනේ. ඒකට මොකද කරන්නේ? Soap containing salt is centrifuged. Right? ඒක highlight කරන්න. Wet soap containing salt is centrifuged. ඇයි එහෙම කරන්නේ? Soap does not dissolve in water and foam well. Foam well කියන්නේ අර foam එක හදන්නනේ පෙන හදන්නේ sodium chloride තියෙනකොට. Foam එක කියන්නේ පෙන පෙන.
ඔතන මේ when NaCl is present in soap, soap does not dissolve in water and
foam well. Foam කියන්නේ පෙන හැදෙන්නේ නැහැ කියන්නේ. Foaming
අපි ඔතන නිකන් foam හැදෙන එක නෙවෙයිද කියන්නේ?
නෑ නෑ නෑ. ඒ කියන්නේ පෙන හැදෙන්නේ නැහැ කියන එක. ඒ කියන්නේ දැන් සබන් වතුරේ දාලා මෙහෙම මේව කරාන් පස්සේ මොනවා වෙන්න ඕනද? ෆෝම් එකේ ඉන්න බෑ. සෝල්ට් තිබ්බොත් මොකද වෙන්නේ? ෆෝම් එකේ ඉන්නේ නැහැ. ඇයි? ඩිසෝල්ව් වෙන්නේ නැහැ. ඔව්. ඊවේ ගොඩක් මේව අඩු ඇති. ඒ කියන්නේ ගොඩක් ඇත්තේ ඔයිල් එක. කෝස්ටික් සෝඩා අඩුවෙන් දාලා ඇත්තේ. එතකොට ඇත්තටම සෝප් හැදෙනවා අඩුයි. සෝප් තියෙන්නේ සර්ටන් amount එකයි. වැඩිපුර තියෙන්නේ අර මොකක් හරි ඉන්ග්‍රීඩියන්ට් එක ඔයිල් එක පාවිච්චි කරන ඒවා. ඒතර ඒකයි පෙනේ ඉන්නේ නැත්තේ සාමාන්‍යයෙන්. පෙනේ ඉන්නේ නැති එක හොඳයිද නැද්ද? ඈ? ඒ කියන්නේ ෆෝම් එනවයි කියලා කියන්නේ අර යාගේ මේ නෑ. ඒ කියන්නේ cleaning power එක වැඩි. cleaning power එක වැඩි. but the cleaning power වැඩි කියලා කියන්නේ it removes the sebum or the oil, the natural oil in the skin as well. So that damages the skin. Right? So if you are like applying a soap in your body, it should have a lesser foaming effect because it's safe for your body and skin, basically the skin. But if you are using it to wash the clothes, greater the foaming index, better the soap, because more the soap foam, more the cleaning power is there. එහෙමයි. يعني ෆෝම් එක එන්නේ නැහැ කියලා කියන්නේ ස්කින් එකට හොඳයි. ඇත්තට. මොකද නැත්නම් ස්කින් එකේ තියෙන මේ වලේට ගලවනවා. ගලවම ස්කින් එක ඩ්‍රයි වෙනවා. ඊට පස්සේ ඕක ඉන්ෆෙක්ට් වෙනවා පට ගාලා. එස කසන්න ගන්නවා. ඒ වගේ කචල් තියෙනවා. ඒ වගේ තව ගොඩාක් ඒවා තියෙනවා. ඒ කියන්නේ සාමාන්‍යයෙන් ඒ ගාන සෝප් එකක් ඒකේ සමහරක් වෙලාවට පොඩි වැක්ස් එකක් තියෙනවා. There's a wax layer of it. Can't tell exactly because of which compound, but there's sort of like a wax layer there. If you didn't use the soap for, sometimes it's for even 1 day, you feel like a layer of something is there in your skin. Haven't you experienced that? You never been like 1 day without using soap? Oh, that's why. So if you stayed like without using soap 1 day, the maximum 3 days you can stay. Like I mean like you can stay more than the 3 days. You will feel sort of like a layer is there. So you can't like undo it without using the soap. That we have got adapted to use it. But the truth is, soap is not can't say a bad thing, but not the best thing to apply on your skin. Something organic is better. Something organic is always better than the chemicals applied. It's always so, right? Right. Then the aqueous salt solution is separated from the soap after the centrifugation. Then the NaCl content of the soap is reduced to 5%. Right. The unreacted NaOH content is reduced to 3%. Water is about 31%. The presence of NaOH in the soap is harmful to the consumer. Soap with high caustic soda content can cause severe damage to the skin and delicate tissue such as the eyes. Therefore, citric acid, phosphoric acid or free fatty acids from coconut oil are added to neutralize very small amounts of NaOH. Highlighted. Citric acid, phosphoric acid, free fatty acids from coconut oil are added to neutralize the very small amount of NaOH. Right. After the salts are removed, the water in the soap needed to be removed. The reduced water content to 12%. The soap is heated about 120 degrees of Celsius and sprayed into a low pressure zone to disperse it into fine droplets. Here, the water gains heat to evaporate which lowers the temperature. Did I say like decrease the temperature? It actually increases the temperature and evaporates, right? So is water gains the heat to evaporate, which lowers the temperature of the soap bubbles. The soap is stored in a low pressure vessel. The water vapor is removed. The dry soap is separated. The dry soap is mixed with fillers, pigments and fragrances and shaped as required to produce the finished soap, right? So that's what happens, right? That's it. Now come to the detergents, right? Detergent is a type of cleaning agent. It is available in powder or liquid forms, right? Detergents are used to clean dishes and other hard surfaces. The main ingredient in detergent is sodium alkyl benzene sulfate, which is this. Highlight it. Sodium alkyl benzene sulfate. Now, can this be in your soap? No, because this has more cleaning power, which means like it takes out all the things in your skin, including sometimes the skin, the oil on your, like the natural oil on your surface. So it will make you like really dry. Oh, ගොරෝසු වෙනවා, dry වෙනවා. එහෙම පාවිච්චි කරාන් පස්සේ ඊට පස්සේ කාලයක් යනකොට හැම යනවා. ඒකේ ප්‍රශ්න එනවා. හාපි ගාලා දාන්නේ.
හාපි එකේ තෝය වගේ.
ඔව්.
ඒකේ ඇසිඩ් එක.
ඒ කියන්නේ මෙන්න මේ සල්ෆේට් සම ගොඩක් වෙලාවට එන්නේ. මෙන්න මේ සල්ෆේට් එකේ තමයි ওই පවර් එක තියෙන්නේ. ඒ කියන්නේ නෙගටිව් අයන් එක. කොරෝසිව්ම නෙමෙයි. ඒ කියන්නේ කොරෝසිව් කියන්නේ sodium hydroxide bases acids are corrosive. Now these are like can't say corrosive. They are like taking all the oil sort of layers out. Coca-Cola. Coca-Cola is not a detergent or anything. Huh? Yeah. I don't know about that. Maybe they're putting the detergents into it. Or clean in a math. But I don't know if it's true or not. Dala baldiyo? Try it at home and tell. අපරාධි ඔයාලනේ easy ගන්න. කපනවා. හරිද? එතකොට මෙන්න මේක මොකද්ද? Sodium alkyl benzene sulfate. You have to remember this. This structure can come to the structured assay part to identify. What is this? Sodium alkyl benzene sulfate. STP. No, not STP. STP is a different case. Huh? Yeah, SABS. There's no any short form for that. You just have to remember it. Sodium alkyl benzene sulfate. That's it. STPs are different. Sodium triphosphates are the STPs, right? So the sodium triphosphate, sodium sulfate, zeolite, sodium carbide, and methyl cellulose are used as additives, right? So මේක දාන්න හින දරුණු additives ටික දාලා දිනනවා. Sodium triphosphate, sodium sulfate, zeolite, sodium carbide and methyl cellulose are used as additives. All these components are dissolved in water. Highlight करें. Sodium triphosphate, sodium sulfate, zeolite, sodium carbide, methyl cellulose are used as additives. අරකේ එහෙම මොකද additives විදිහට මේව දාන්නේ? මේක දානවා. All these components are dissolved in water. This process is exothermic. This is because the STP hydration is exothermic. Exothermic when STP in down. Then it is further heated to 85 degrees of Celsius and stirred well until a homogeneous solution is obtained. Finally, a very thick paste-like solution is obtained. නේ අර ටිකක් ගණට තියෙනනේ යන් දියාරුවට උකුවට වැක්කන එකක් හැදෙනවා. Very thick paste is very thick paste-like solution is obtained. This paste is injected into a low-pressure chamber. The small droplets dry quickly. Fragrance are mixed with these dry droplets and added them to the market as detergents. Right. So that's the process of making the detergents. Then this one, paint production is important. Right. The history of paint dates back to about 3,500 years. සුද්දා වැද්ද කාලේ අපි paint use කරලා තියෙන එක තමයි මේ කියලා තියෙන්නේ 3500 years back යනවා. And historical information from the Egypt has revealed that there was a certain technology and progress there. A color known as Egyptian blue. Egyptian blue. Yeah, the turquoise color. Turquoise has a blue color. I think that is the color. Now, the calcium copper sulfate has been used since ancient times. The Sigiriya frieze course also provides evidence for the production of colors and color combinations that the people living in this island at that time had. අපි අර වෙනස් different color. මේව තමයි. ඔව්. Right? So අපි පාවිච්චි කරලා තියෙන කලර්ස් නේ අපි සීගිරි ලලනාව එහෙමනේ. කට්ටිය ඉස්සර ඇඳපුවා තමයි. Right? ඒ සීගිරිය ක්ලබ් එකක් කියලා නේ කියේ. සීගිරිය ක්ලබ් එක. කියන්නේ රජුරු ආතල් දාපු තැන. ඒකේ නිවුට් තමයි ඉතින් ඇඳලා තියෙන්නේ. ඕකේ මොකෝනේ බුදු පිළිම අදින්නේ. නිවුට් තමයි ඇඳලා තියෙන්නේ. ක්ලබ් එකනේ. Right? It is also a good opportunity to demonstrate that we also had the technical knowledge to produce and mix the necessary raw materials to create mural that would last for a long time, facing various weather conditions using colors, right? So why do we use paint? There are two primary purposes to using paints. One is for beauty, the other one is for security, right? Beauty and security. Or some area anti-fungus, the weather shields are there. Right. When determining a paint composition, it is very important to know whether it is intended to be applied to a metal surface, wood surface or a cement surface. You should also be aware of the environmental conditions to which those surfaces will be exposed. Some examples include the following. Surfaces frequently exposed to sunlight. මේ තියෙන එක එක surface වර්ග මේ surface එක අනුව ඔයා පාවිච්චි කරන paint එක වෙනස් වෙනවා. So the surface frequently exposed to the sunlight. Then the surfaces that frequently come into contact with the salty water uses different paints. Surfaces that frequently exposed to water of moisture. Surfaces exposed to high temperatures. Surfaces exposed to high and low temperatures. Frictional surfaces, surfaces that come into contact with organic compounds such as oil and grease. Surfaces exposed to fast wind currents. එක එක surface වලට වෙන වෙනම paints වර්ග හදනවා. සාමාන්‍යයෙන් ඔය වෙනම scientistලා ඉන්නවා ඒගොල්ලෝ ඔය mixtures test කරනවා. එක එක compounds දාලා මෙහෙම කලවම් කරලා අර වෙදවප්ප දානවා වගේ අන්තිමට බලනවා මොකක්ද ඉන්නේ කියලා. ඒ කියන්නේ එක එක trial methods තියෙනවා. ඒ දාලා ඒ විදිහට තමයි හදන්නේ. ඊට පස්සේ ඒක apply කරලා බලලා stability එක තියෙනවා නම් අන්න පාවිච්චි කරන්න ගන්න. හැබැයි ඒව කවදාවත් ඒගොල්ලන්ට හම්බෙන්නේ නෑ. ඒව අයිති වෙන්නේ කාටද? කම්පැනි එකට තමයි. ඒව තමයි weather shield, anti fungus අනම්මනම් කියලා ඉන්නේ ඒව. එක එක වර්ගයව තියෙනවා. Composition of a paint solution, right? Now these things should be there in the paint solution. There are 4 basic types of components associated with the paint solution. මේවා ඊටාම වැදගත්. You have to remember it. What are the components? First one is binder. Now what is a binder here? Binder is usually polymer. We discussed this under somewhere. I can remember we discussed this under the polymers. Did we? I think we did. Under the polymers we discussed about under the polystyrene. Polyester. So polyester is one of the binders or the fillers which we dissolve in where? Acetone. Even acetone or the petrol, we can dissolve the styrofoam or the rigifoam, right? The scientific form is polystyrene, polyester, right? Polystyrene. So what happens when you dissolve it? It becomes a binder, and when you apply it in a surface, the solvent, what happens to the solvent? Now you dissolve the polyester in a thinner or a petrol. Now you have a solution of the solution of polyester dissolved. There is a binder, and you apply it on a surface. What happens to the solvent? It evaporates. What happens to the binder? It sticks to the wall. That's the binder, right? And if the binder has any pigments, it sticks with the pigment, so it's give a color, right? That's how it happens. And the solvent, as in our case, we took the thinner or the in our case, like in the styrofoam or the rigid form, we took petrol or acetone, right? So solvent can differ, like depending on the type of the paint, right? There can be two types of paints. What are the two types of paints, like depending on the solvent? Emulsion and enamel. So the emulsion uses water and the enamel uses the organic solutions, right? They are using the organic solution. And the pigments are there to what? Emulsion is who? One of the persons. So the pigments are used for what? The pigments are used for the colors. Pigments are used for the colors, and the additives are used for the other causes, like we discussed, the antifungal, likewise, weather shields, sort of everything, the additives are used. Now come to the binder. The binder is a basis for the creating dry film by attracting pigment particles to the surface. Therefore, the main component of the paint solution is a binder, right? This binder is a polymer material, as we discussed, like the polyester. When the solvent evaporates and is removed, these polymer molecules connect with each other and form network structures. It forms a network structure, right? This network structure creates a dry paint film, right? So the dry paint film is created by this polymer, right? Dry paint film එක හදනවා. Right. It is a material that builds up attractive forces with the surface, so it sticks tightly to the surface. It's also build up attractive forces with the pigment particles. Therefore, the binder sticks to the pigment particles and also sticks with the surface, forming a dry film. Do you understand that? It sticks with the pigment and as well as the wall, so it gives a colorful wall at the end, right? Right. The polymer materials commonly used in binders. So these are the polymers. What are the polymers? You have to remember these ones. At least 2 or 3 you have to remember. Alkyd polymers, right? Then the acrylic polymers. Sounds like same. Alkyd, acrylic. The other thing is polyurethane polymers. Polyurethane. Yeah, polyurethane. Polythene mura wagine polyurethane. Polyurethane. Polythene mura. Or polyurethane comes close to. Now the epoxy polymers, I think you have never heard of it. Epoxy resins are there. Never heard of it. Like mixing 2 of the liquids, you form like a very hard and a thick gum. ඒවට තමයි epoxy කියන්නේ. hardware වල තියෙන දෙකක් mix කරලා ගන්න. Lee වලට epoxy. Those are the epoxy resin. It's one of the polymers or the fillers or the binders, right? And the phenolic polymers. So 5 types are there: alkyd, acrylic, polyurethane, epoxy, and phenolic. Phenol, තියෙන compound එක. Phenolic කියන්නේ ඒකයි. Right? Now the polymers that are resistant to UV rays should be used when manufacturing paints that are applied to surfaces that are frequently exposed to the sunlight. ගොඩාක් sunlight එකට expose වෙනවා නම් UV resistant ඒවා පාවිච්චි කරන්න ඕන. Now these are the additives. හරි. මේ වගේ ඒවාට පාවිච්චි කරන additives කියන්නේ. Now tell me what are the main parts of a paint? Binder, solvent, pigments. So it's easy to remember, right? Right. Then come to the solvent. The flow properties of paint solution are due to the solvent. Now the flow properties is what? the viscosity or the flowability, right? The thickness simply. The solvent provides a medium for the uniform dispersion of the binder, pigment and additives. In some paint formulations, water is used as a solvent, right? What do you use water as a solvent? In which sort of the paints? Emulsions, right? This has several advantages. Now these are the advantages of solvent, water as a solvent, right? What are the advantages of water using as a solvent? Water is recyclable and very profitable, not an air pollutant, non-toxic, no risk of fire, right? It got thrown out. Solvent එකක් විදිහට water වල තියෙන importance. Water is a recyclable solvent, very profitable, not an air pollutant, non-toxic solvent, no risk of fire is there. Right? Come to this one. Organic solvents are used in the production of some paints. When the wet paint film dries, these organic solvents evaporate and enter the atmosphere. These organic solvents are air pollutants. Like in which paints? Which type of paints? The water is using in the emulsions, other ones are enamels. So in the enamels, they are using the organic solvents like the thinners. So what happens when you are applying the thinners? The thinner will evaporate to the atmosphere. So the atmosphere will get polluted, right? So that's the issue. These organic solvents are air pollutants. They are toxic. There is also a risk of fire during the production process. For this reason, international attention has been focused on the need to move away from the use of organic solvents and focus on producing paints using matter, right? The solvent used in the production of paints, which are commercially known as emulsion paints, is water. Highlight it. Emulsion paints is water. The solvent is water, right? Organic solvents are used to produce the following paints. These types of solvents used in the production of paints, right? So what are the solvents? Water is used, mineral turpentine is used, xylene is used, toluene is used, butanol and isopropanol are used, ketones are used. At least remember 2 or 3, right? The solvents, can ask. Next one, the pigments. Organic pigments and inorganic pigments are used in paint production. Inorganic pigments are very fine particles. Pigments give color to the dry paint film, right? So what does the pigment do? It gives a color to the dry paint film. Inorganic pigments are used to cover the surface and to give color. Some inorganic pigments, for example calcium carbonate, do not give color, right? Now the pigments like calcium carbonate do not give color. Those are usually the fillers. Do not give color to the paint film, nor do they cover the surface. Such pigments are called extenders. Now the calcium carbonate is a extender, right? It's one of the extenders. They are important only as fillers, right? So extenders are like like they are using coats, ne? So the primary coat is a extender, ne? Extender එකක් විදිහට තමයි primary coat එක ගන්න. ඒක අර ඊළඟ coat එකට support එකක්, right? So there are no any pigments. They are usually the fillers, right? The inorganic pigment that give color, titanium dioxide, මෙන්න important. Titanium dioxide. මොනවාද දෙන්නේ color එක titanium dioxide? White color. And the zinc chromate gives what? Yellow color. Iron oxide, black. Black color is given, right? And these are the filling materials. What are the filling materials? Quartz, barium sulfate, creoline clay, limestone, right? So these are the filling materials. So when the amount of these fillers or colored pigments is increased, the gloss of the paint film decreases. So more the color pigments, the glossiness goes and the mattness occurs, right? The matte color is occurred, right? The paint film becomes rough. It also provides additional strength to the paint film. The higher the pigments of these pigment particles, the greater the ability to cover the surface. For example, titanium oxide has the highest pigment among these pigments. So it is so its ability to cover the surface with white is very high. A low amount of titanium dioxide can cover a large area of the surface with white is very high. A low amount of titanium oxide can cover a large area of the surface with white, right? Yeah, it has repeated. Make a repeat to that. Right. Then the additives. Additives are substances used in small amount to improve the properties of paints, right? Some additives prevent foaming. एक आप ये highlight करेगा. Substances used in small amount to improve the properties of paint, sort of like different properties. Some additives prevent foaming during the manufacturing process. It can prevent foaming. Foam වෙන එක අර පේන්ට් එකක් දැකලා තියෙනවා සමහර නිකන් ක්වොලිටි අඩු පේන්ට් වල පොඩි ෆෝමින් එකක් එනවා. ඒක පේන්ට් එකට හොඳ නැහැ. අන්න ඒක අඩු කරන්න දාන්න ඕන වෙනම additives. Anti foaming agents දාන්න ඕන. නේ. Anti foam වෙනවා ඊට පස්සේ. During the manufacturing process by mixing them they help keep the paint solution stable for a long time without separating the layers. Some additives make it easier to apply the paint, right? Now the thickness. Thickness are used to prevent the defects that may occur after the paint is applied due to the flow properties of the paint solution. Thickness increases the viscosity of the paint solution. An example of a thickener used in the production of the emulsion paint is hydroxyethyl cellulose. This is a thickener. What if the thickness are not there? එතකොට නිකන් අර මේ පේන්ට් එක වැක්කිරෙන්නේ කියන්නේ අර thickness එක නේ. ඔව් වතුර වගේ. වතුර වගේ නිකන් චාටර් ඒක. තීන්ත ක්වොලිටි එකක් ඉන්නේ නේ. සමහර ඒවා තියෙන. ඒ වගේ ඒවා තමයි foaming index එකත් වැඩි. thickness එක වැඩි වෙනකොට foaming index එක අඩුයි. right. ඒතර thickness එකක් තමයි මොකද්ද? hydroxyethyl cellulose අහන්න පුළුවන් HEC thickness එකක්. Pigment wetting agent, right? The pigment particles need to be wetted by the liquid medium obtaining the polymer or the binder. Otherwise, defects will occur due to the presence of fine air layer between the pigment particles and the polymers and improper bonding. This will cause mixing difficulties. Therefore, these additives are added to ensure that the pigment particles interact with the liquid medium containing the polymer. ඒ කියන්නේ දැන් pigment එක සමහරක් වෙලාවට polymer එකත් එක්ක interact වෙන්නේ නැත්තම් ඒ interact කරගෙන අපිට මොකක් දාන්න වෙනවද? pigment wetting agent එකක් දාන්න වෙනවා. දැන් ඒ කියන්නේ දැන් pigment එක polymer එකත් එක්ක mix වෙන්නේ නැහැ. නැත්තම් binder එකත් එක්ක mix වෙන්නේ නැහැ. ඒතර binder එකත් එක්ක mix කරගන්න pigment wetting agent එකක් දානවා. pigment wetting agent එක මොකද කරන්නේ? pigment එකයි binder එකයි mix කරනවා. අල්ල ගන්නවා. එතකොට මොකද වෙන්නේ? Some parts of the pigment wetting molecule interact very well with the pigment. Another part of the molecule interact very well with the binder. It's like the soap. Can you remember? So it has here. It has two parts. One is reacting with the DC pigment. One is reacting with the pigment. The other part is reacting with the binder. See? Now this part, X parts are reacting with the pigment. The Y parts are the area to be treated with the binder. The Y parts are reacting with the binder. Now this part is also important. This can come to any of the questions. Pigment wetting agent. Pigment wetting agent. Now this is the pigment, this is the pigment wetting agent, and this is how it works. Right? Right. See, the anti-foaming agent is there. Right? In the production of emulsion paints, foaming during the mixing process hinders the mixing process. If this foam remains stable, it becomes difficult to produce the paint. Anti-foaming agents are added to prevent the foaming. Foam එක හැදෙන එක පෙන හැදෙන එක අඩු කරනවා. In addition, there are a number of other additive groups. Some paint solutions develop a thin film over time. දැකලා තියෙනවද කාලයක් යනකොට නිකන් thin film එකක් හැදෙනවා නිකන් නෑ ඒ කියන්නේ ඔව් ෆ්ලේක් වෙනවා කියන්නේ එයා හදනවා ලේයර් එකක් අර බෙරේ වගේ කියන්නේ පේන්ට් එක උඩ හදනවා පොඩි ලේයර් එකක් වගේ නේ ඔව් පියන ඇරියාම පස්සේ නිකන් තියෙනවා පොඩි පටලයක් වගේ එකක් හරි which can be seen when the paint container is open anti skinning agents ඒකට දාන්නේ මොනවාද ඒකට දාන්නේ anti skinning agent can skin එක හැදෙන්න දෙන්නේ අර කියන්නේ it's like a skin right it's like a skin so anti skinning agent is used to get rid of the like the skin or the thin films right added to prevent this film for forming when the paint solution is stored. Some paint surface become slippery when they dry right so some surfaces are slippery right when they dry. Anti skid agents, what do you use for that? Remember those things. Anti skid agents are used to slippery surfaces right so added to prevent this so some paint surfaces develop static electricity when they dry like in the like if you are like me in a plane the plane surfaces sort of like they when they like moving in the air they can make the static charges and me hena ගහන්න පුළුවන් යනකොට that can happen so to avoid that you have to use the different paint types to reduce the static charges. This type of static electricity builds up especially when the outer surface of an aircraft is in rapid contact with the dry air because of the resistance right. Anti-electrostatic agents for that they use anti-electrostatic agents are added to prevent this. In addition, various compounds, the biocides likewise, are added to prevent the growth of fungus and bacteria. Right? Biocides are also used. Oh. Antibacterial, antifungal, තියෙන්නේ අර එක එක
මොකක් හරි පේන්ට් එකක් ගාලා ඒකේ අර ළමයි ඉඳලා ඒක ඇඳුම්ත් ඒක වොෂ් කරන්න පුළුවන් ඒකට
එහෙම තියෙනවද පේන්ට්?
ඒ කියන්නේ පේන්ට් එක බිත්ති වල අඳින ඒවා වොෂ් කරන්න පුළුවන්.
පේන්ට්ස් වර්ග තියෙන්නේ ඔව් ඇති. මම දන්නේ ඒක මොනවද කියලා.
ෆිල්ම් එකක් හදන්න ඕනේ.
It's really hard to tell because
washing කරනවා.
ඔව් ඒ කියන්නේ ඒ surface එකත් එක්ක contact කරගන්නේ නැහැ නේ. එහෙම එකක් ඇත්තේ. ඒ කියන්නේ ඒ ink එකත් එක්ක වෙන කවුරුත් contact කරගන්නේ නැහැ. nano coating එකක් වගේ දන්නෙත් නේ. nano coating වලත් එහෙම contact කරන්නේ අනිත් පැත්තට. Right, drying of the wet paint film. හරි. wet paint film එක dry වෙන විදිය. ඒ කියන්නේ apply කරාන් පස්සේ wet paint film එක dry වෙන විදිය දෙකක් තියෙනවා මොනවාද? Drying without chemical reactions. This is about the emulsions. Emulsions වල chemical reaction එකක් වෙන්නේ නැහැ මොකද වෙන්නේ? water molecules ටික evaporate වෙලා යනවා. එතකොට bind එක compact වෙනවා. compact වෙලා layer එක හදනවා. Right? The other one is drying due to the chemical reaction. Right? So drying due to the chemical reaction happens in the what? Enamels. Right? In the enamels, kind of a chemical reaction occurs and a kind of a bonding happens like in the we discussed under the polymers. There's vulcanizing the rubbers. They are forming a bond, sulfur bonding. Likewise, in the drying due to the chemical reactions, there is a bonding occur. So because of the bonding, the drying happens, or the thin layer of the film is produced because of the bonding reaction. Right. So two types of drying of the wet paint are there. right? So without chemical reaction and with chemical reaction. Now come to the drying without chemical reaction. This is emulsions, right? The solvent in the thin wet film gradually evaporates. Due to this, the polymer concentration increases. The distance between the polymer molecules decrease. As the polymer molecules come closer, intermolecular forces of attraction between them cause the molecules to come closer to each other and hold them, right? Also, the molecules maintain their attraction with the surface and become a dry film that sticks to the surface. This dry film cannot be dissolved by the solvent, right? Highlight it. Now, if you use the water to as the solvent and you apply it in the wall, and after drying it, you then again put some water on it on the surface, would the paint dissolve back? No, doesn't happen, right? So this dry film cannot be redissolved by the solvent, right? Can't be redissolved, doesn't happen. For example, in emulsion paints, now the drying without chemical reaction, the example is emulsion paints, right? For an example, in emulsion paints, what happens is that the water evaporates and the polymer molecule binds to each other through intermolecular forces of attraction, creating a dry film. However, this dry film of paint cannot be redissolved by adding water, right? However, it can be dissolved by other organic solvent. එතකොට ඒකට තින හරි මොනවා හරි දැම්මම එතකොට dissolve වෙනවා. හරි. Can be dissolved by other organic solvents, right? Right. So the next part, drying due to the chemical reactions. The polymer molecules in the paint solution are not chemically bonded to each other. When some paint solutions create a wet paint film, chemical bonds like the crosslinks form between the polymer molecules, right? Now the chemical bonds or the crosslinks form between the polymer molecules. After the solvent is added, solvent add කරාම crosslinks හැදෙනවා polymer එකේ. Forming a web. The solvent also evaporates as the film is formed. Because the molecules in this web are bonded to each other, it becomes a strong dry film. එතන මේක වෙන්නේ අර cross linkage හැදෙනවා අර solvent එකේ හින්දා. ඒ විදිහට තමයි ආ dry වෙන්නේ. Right. There are two ways in which these chemical reactions can occur. Crosslinks are formed between the polymer molecules in the wet paint film by atmospheric oxygen. අර crosslink එක හැදෙන්න පුළුවන් atmospheric oxygen වලින් හැදෙන්න පුළුවන්. That is one way of happening it. Catalysts are used to catalyze this reaction. These are called dryers, right? ඒ කියන්නේ catalyst වලට කියන්නේ dryers කියලා. හොඳයි. Catalysts are used to catalyze this reaction and ඒගොල්ලන්ට කියනවා dryers කියලා. Catalysts වලට තමයි dryers කියන්නේ. These catalysts are manganese, cobalt, lead. Manganese, cobalt, lead and zirconium compounds. Since cobalt and lead compounds are toxic, the use of such dryers has had to be reduced. Alkyd paints dry in this way due to the process of cross-linking between polymer molecules by atmospheric oxygen. Such dried films cannot be dissolved again by any solvent. ඒ වගේ ඒවා cannot be dissolved again by any solvent. හරි. Oxygen වලින් cross links හදන ඒවා cannot be dissolved by any solvent. In some types of paint, the components required to form crosslinks between polymer molecules are available as separate package, 2-pack paints. අර epoxy resin එකේ වගේ 2-pack paints එන්නේ. Before applying the paint, the second component is mixed well as needed in the paint solution, and the paint is applied quickly. Right? Right. Now come to the next topic, paint types. We can see that there are many types of paints available in the market. These paints can be divided into different types. For example, according to the surface to be coated, wooden surfaces and metal surfaces, right? by the type of solvent and depending on the layer applied. Highlight those things. According to the surface, wood or metal, by the type of solvent, water, organic, depending on the layer applied. Could be a primer, undercoat or a top coat, right? Right. So there are several benefits of applying a primer. The second and final coat of the paint does not peel off easy because of it adheres well to the surface, right? Now this is about the primer, right? So primer is the first coat we are applying on a surface before applying the the final coat, which is the rubber paint, right? Usually we are applying the rubber paint at the final. So finally before acting, yeah, right? No. Rubber paints are applied on the walls. Primer එකක් ගහනවද කියලා දාන්නේ? ගහනවද? ඒක මාරියටම දාන්නේ. ගහනවනේ. ඒ varnish එකක්. Primer එකක්ද ගහන්නේ? Varnish is also primer. Yeah, varnish is also one of the primers. The second and final coat paint does not peel off easily because of it adheres well to the surface. ඒ කියන්නේ දැන් අපි හිතමු කටු බිත්තියකට ගැහුවයි කියලා. රබර් පේන්ට් එක මොකද වෙන්නේ? දැන් කෑලි කෑලි ගලවලා ගතේ. අර කටුනේ තියෙන්නේ. හැබැයි ප්‍රයිමර් එකක් ගහලා ඒ අර ඒ ටික වැහුවාන් පස්සේ ප්‍රයිමර් එක උඩ ගහන්න පුළුවන්. එතකොට බිත්තියට අල්ලලා ඉන්නේ. Right. Provide some protection to the surface until the second and final surface coating is applied. මේව important නේද? Prevent the absorption of water vapor and oxidation by atmospheric oxygen. Then the discoloration occurs due to the different pigments in wood reaching the paint surface. This can be prevented by using a primer. Preventing rusting of the metal nails used in the wood. Before applying the primer, the surface should be thoroughly cleaned and prepared as required by sanding with sandpaper, right? Right. So sealer is a type of paint that works very similar to the primer, right? So sealer, we call it a sealer, right? Sealer is a type of paint similar to a primer. For old cement surfaces with many cracks, a sealer should be applied first. It closes the cracks in the surface and gives the surface a smooth appearance, right? Cracks තියෙන වහන තමයි ගොඩක් වෙලාට seal එකක් ගහන්නේ, right? Therefore, the amount of paint used for the second and final coat can be reduced. By reducing the roughness of the surface, the second and final coat helps to provide glossy surface. A sealer coat ensures good adhesion between the base coat and the top coat. Also the surface prevents the passage of air and water until it fills various irregular roughness on the surface and creates a uniform smooth surface. This surface coating is called varnish. So varnish is a primer, which can be colored or colorless, right? Right, so the biodiesel is the next, we will discuss it the next day, and by the next day hopefully we can finish the industries, right? So we will try to start early so we can finish it by the next day. ඉවර කරගන්න බලමු. ආසමන්ක. ලස්සනයි කියලා කිව්වෙත් දැන්. ලස්සනයි කියලා කිව්ව කියලා හිතුවත් දන්නේ. අයියෝ ආවරු.